Hi everyone, and welcome back to my YouTube channel. It has
been such a long time since I've posted a video for you all. So I do hope that after this video, I will post some more to help you all
exceed, succeed, and improve in math, okay? All right. Anyway, so this video is about completing the square. We're going to talk about the turning point. We're going to talk about determining whether it is a maximum or minimum, and also calculating the roots of the equation and the axis of symmetry. So don't forget to like, subscribe, and share my video. Stay tuned. All right, so this is the question that we're going to do in this tutorial. I have another question as well, but if the video is taking too long, I will do the question in another video, right? But before we do this, we need to touch on some basic concepts. So let's just go back a bit so I can touch on some basic concepts before we do that question. All right, so first things first, we need to know the basic form of a quadratic equation. It's ax squared plus bx plus c, all right, equal to 0. Where, for example, if you have 2x squared plus 3x plus 4 equal to 0, we can clearly see that a is 2, all right? We can see that b is 3, and we can also see that c is 4, right? I tend to always take the sign with it. I didn't take the sign here, but I usually take the sign with it so that students wouldn't get confused now. So like, for example, if we had 3x squared minus 4x, how about we put a minus there as well, plus 6, all right? And we need to determine the values of a, b, and c. We line it up. This is ax squared plus bx plus c, all right? So we can clearly see that a is minus 3. We can also see that b is minus 4. And we can also see that c is positive 6. All right. So if you notice, I take the sign. So when I'm looking at b, I take the sign with it. So b is minus 4, c is positive 6, and a is minus 3. All right. Now, with knowing that, we also need to know that if a curve is shaped like this here is called the minimum point. All right. Well, it's actually turning point right in the bottom here. Sorry about that. So right in the bottom here, right, is called the turning point of the curve. And this turning point is called a minimum point. All right. Now, if the curve is shaped like this is the turning point because, I mean, you know, you can clearly see the curve goes in this direction. And at this point, it goes down instead. Here, the curve goes down, and at this point, it goes up instead. Right? So this is the turning point again. All right. And this is a maximum. All right. So if the curve shaped like this, it's a minimum. If it's shaped like that, it's a maximum. And to calculate this turning point is minus hk. All right. And this turning point, again, minus hk to determine the turning point. And where do these values come from? It comes from when we complete the square. So usually the question will say to complete the square, or they might say to write in a particular form. And the form they are talking about is a, open bracket, x plus h squared plus k. And this is where your h and your k comes from. So after you complete the square and you write your quadratic equation in this form, you can then determine your values of h and k so you can get your turning point. All right. Also, to determine if it's a maximum, you look at the value of a. Well, you look at the sign in front of a, I should say. All right. So if a is less than 0, right? That's a less than sign there. If a is less than 0, it's a maximum. And if a is greater than 0, it's a minimum. So, for example, if the question said 5x squared plus 3x plus 4, at this point, we can clearly see that a is greater than 0. So therefore, this function is a, look at it, greater than 0 is a minimum. So therefore, this function is a minimum. Or the turning point occurs with a minimum value, right? Now, if we had minus 2x squared plus 2x minus 3, right? A is now minus 2. So since A is equal to -2, which is since A is less than 0, all right, we have a negative, so therefore it's a maximum. All right, so we have A is greater than 0, minimum, A is less than 0, maximum. All right, so that's just the basics in a quick nutshell. All right, so moving on, we can attempt to do this question. So this question says that write f of x equals to x squared plus 12x plus 32 in the form ax plus h squared plus k, where a, h, and k are real numbers. All right, so basically they want us to complete the square. They didn't just come out and say complete the square, but when they say to write it in this form, they mean to complete the square, right? I wrote that somewhere here, so here, right? So once they say to write it in this form, they mean to complete the square. So let's attempt to complete the square, right? So it's x squared plus 12x plus 32. Let's write it on the side. So we have x squared plus 12x plus 32, right? So we put our brackets, we put our square, and we put our x. Now, x squared gives back the x squared, all right? Now, the number that goes here is always half of the coefficient of x, right? The coefficient of x, it means the number in front of x. So if you have 4x, the coefficient of x is 4. If you have 2x, the coefficient of x is 2. So the coefficient of x here is 12. So you're taking half of 12, so you'll get 6. Well, half of positive 12, I should say. So you get positive 6. You have to bring down your 32. All right. When you bring down your 32, you have to subtract the square of the number inside of here. All right. So you're subtracting 6 squared. Now this leaves us with x plus 6 squared plus 32. Take away 6 squared. Right? Anything squared means you multiplied by itself 2 times. So 6 squared means 6 multiplied by 6. All right. If you have in trouble with this, you can check my YouTube tutorial on indices, because a lot of students put 6 squared is 6 by 2. All right. If you're doing that, you need to do a little extra work. All right. All right. So 6 squared is 36. And now we're going to simplify what we have here. All right. So this gives us x plus 6 squared minus 4, right? So this is in the form of a, open bracket, x plus h squared plus k, where a is 1, all right? Or we could even see a on top here. Now there is no number in front of x squared, so it's understood to be 1x squared, all right? That's not 0x squared. That's another mistake students make. It cannot be 0, right? It's not 0. If it was 0, it would not have been there, right? If you are seeing an x squared term, it means it exists, and it's not 2, so it's 1, right? So it's 1x squared, right? So where a is equals to 1, h is 6, and k is minus 4, right? If you wish, you can draw the circle thing I did before, like you highlight your h is 6, you highlight your k is minus 4, right? Let's see what else the question asks us to do. So we just did the first one, right? So we wrote it in this form, which is to complete the square. The second one, hence or otherwise, determine the turning point of f of x. Well, determining the turning point of f of x is a minimum or maximum. So they basically want us to determine if the turning point of f of x is a minimum or maximum. All right, there's a little typo there. All right, so back to our first note. If a is greater than 0 is a minimum, if a is less than 0 is a maximum. All right. So in this question, we determine a as 1. All right. And we could have easily got it here. We didn't have to complete the square to determine the value of a. All right. Let me show you. We started off with x squared plus 12x plus 32. So this is part A. Was it A? And then we have a part B now. All right. So part B. Now we can clearly see it here. Okay. But I'm just rewriting it just to show you. So we have x squared plus 12x plus 32. This is in the form of a x squared plus bx plus c. Now a is understood to be 1, all right? So therefore a is equal to 1. Now 1 is greater than 0. So therefore a is greater than 0. And once a is greater than 0, we have a minimum, right? So a minimum means that the curve is shaped like this. All right, and this here, our turning point is a minimum. All right, so the question asks to determine whether the turning point is a minimum or a maximum, and we just realize that it's a minimum. All right, so we did this one now, part 2. We have to determine the value of f of x when this occurs. When they say to determine the value of f of x is like determining the value of y. All right, you know how you state a coordinate, right? You state your coordinate like x comma y. So you need to know your graphs, right? When you're doing this, you need to know your graphs, okay? Right, so x, y. Y is the same thing as f of x. So it could be x, y, or it could be x, f of x. All right, so the question again asks us to state the value of determine the value of f of x when this occurs. So the value of f of x at this point, we have x f of x. All right, and they want us to determine this value here. Now the formula for the turning point, is minus hk. Right, the turning point, if it's a minimum or maximum, is always minus hk. So therefore, we have to determine what minus hk is. So this value here, all right, is minus hk, right? We got h as 6. So if h is 6, all right, let me put that on the side. We can write that down here. If h equal to 6, right, minus h means you just put in a minus sign in front of h. So put in a minus sign in front of h, which is 6, all right? So minus h becomes minus 6 and k is minus 4. All right, so x f of x is minus 6 minus 4. Cool. So x is minus 6, f of x is minus 4. And the question wanted us to determine the value of f of x when this occurs. So the value of f of x is minus 4, not so. F of x is k, which is minus 4. So the value of f of x is minus 4. So the value of f of x at the turning point, right? At the turning point, or at the, or we have again at the minimum point, at the turning point or the minimum point. Let me see. Turning, right? Just imagine there's an end there. At the turning point is what we said, minus 4. Right, cool. Right, and the next part of the question now is part 3. They said to determine the corresponding value of x when this occurs, all right? So we found for f of x, you want to get x. F of x or y, you could say y as well, okay? So let me just erase a little portion of that screen there. So, right, so part C now, we want to determine the corresponding value of x. So we know the turning point is minus 6, minus 4, all right? So f of x is minus 4, x is minus 6. That's basically it. X equal to minus 6. All right, so let me just go through that again, just to make sure you grasp that, right? So the turning point, all right, occurs at minus hk, okay? And we know that this is the x and this is the y value when we are sketching our graph, all right? We got minus h to be, well, h is 6. So if h is 6, minus h would be minus 6. And we worked out k to be minus 4. All right. So to determine the value of f of x when the turning point occurs, all right, this here is always our f of x. And this here is always our x. So this is the x value when the turning point occurs, and this is the f of x value when the turning point occurs. All right, they just use fancy terminologies, right? Determine the value of f of x when this occurs. It basically means what is the y value at the, what we have, minimum, all right? And this one, the corresponding x value. It basically means what is the x value at the minimum or the turning point, because every question is different. All right, so part C. So part C says, define the values of x for which x squared plus 12x plus 32 equal to 0. All right. Now, there are two ways to do this. We can factorize it, or we can use what we had already. All right. Let's see what we had. Let's use what we had at first. Now we could factorize it. Most times students factorize it, okay? So we had x plus 6 all squared take away 4, all right? So let me just rewrite it. What it is, x squared plus 12x plus 32. So we started off with x squared plus 12x plus 32 equal to 0. We started off with that, right? And then we went on to complete the square of that quadratic, and we got x plus 6 squared. Yeah, x plus 6 all squared take away 4. All right. So we got x plus 6 all squared, take away 4, equal to 0. So this quadratic is the same thing as this. It's just written in two different forms. But these two equations are equal. All right. And the question wanted us to find when it's equal to 0. Look at the question again. They said find the values of x for which this is equal to 0. All right. So when the quadratic is equal to 0, they basically want us to solve it. So we can use this method at first because we just completed this way. All we do now is solve it. All right. So we'll end up with x plus 6 squared is equal to, you bring across the 4. It's negative. When it goes across, it becomes positive. All right. So we get x plus 6 is equal to, when you bring across the squared, it becomes the square root of 4. But when you find the square root of a number, the answer could be positive or negative. All right, so we can write our either here. X plus 6 is equal to, well, actually, yeah, anyway, how about we find the square root one time so you guys wouldn't be confused, you know, that would make more sense to do. So let's do that. Let's do that one time. All right, so this gives us x plus 6 is equal to, the square root of 4 is 2. So the answer is plus or minus 2. And then you can put your either x plus 6 is equal to positive 2 or x plus 6 is equal to negative 2. Because it would mean x plus 6 equal to the positive version of 2 or x plus 6 equal to the negative version of 2. Because 2 squared is 4 and negative 2 squared is also 4. All right. So we have x is equal to 2 take away 6. So to bring it across, become negative. So that gives us x is equal to minus 4, or x is equal to negative 2 minus 6. X is equal to 6, 7, 8 minus 8. If you're having trouble with algebra, I have a small tutorial on that could help with basic questions like this down here. I didn't do these. And if you're having trouble with directed numbers, I have a whole long series on directed numbers on my Facebook page, not on YouTube at the moment. All right. Anyway, so the question wanted us to solve it, right? So they said find the values of x, and that is exactly what we did. We used our completed the square version and we solve for x. All right. Alternatively, right, we know when we get a question, x squared plus 12x plus 32 equal to 0, basically you factorize. All right. So x by x gives us x squared, or two numbers when multiplied gives 32 and when added or subtracted gives 12. All right. So we can try 8 and 4, right? 8 times 4 is 32. So we have 8 times 4 gives us 32. We have 8x here, and this is 4x. Now 8x plus 4x is 12x. Right? So we put the plus by the 8 and we put the plus by the 4. If you need help with factorizing, message in the comments and I'll do a factorizing tutorial, okay? Now either the first bracket equals 0 or the second bracket equals 0. So either x plus 8 equal to 0 or the second bracket x plus 4 equal to 0. So we have x is equals to minus 8 or x is equal to minus 4. The same answer as the left-hand side. So whichever way you work it out, you're going to get the correct answer. Cool. All right. So what's the next thing they asked us to do? So part D now, they asked us to sketch the graph of this, clearly showing the minimum points. We already worked on the minimum points. So we have this, the value of the y-intercept. Now, I didn't tell you what that is. So if you have a function or a quadratic equation, x squared plus, well, ax squared plus bx plus c equal to 0. This here is our y-intercept. All right. So that note should have come like in this here. All right. What is our y-intercept? Okay. Right. So our y-intercept in this case is c. Now this is in the form of a x squared plus bx plus c. So clearly c is equals to positive 32. So our y-intercept is positive 32. Our minimum point, we worked it out to be minus 6 minus 4. All right. Minus 6 minus 4. The question actually told us it's a minimum. So it gave away itself there. All right. But that usually happen. All right. And we knew it was a minimum because a was greater than 0. Now the point, so the graph cuts the x-axis. Where the graph cuts the x-axis basically is where y equal to 0. Think about it. If you have a curve, now this is not the curve, I'm just randomly drawing a curve. If you have a curve like this, all right? And it cuts the x-axis at this point. Say this is 2 and this is 1. This coordinate is 2, 0, all right? And this coordinate is 1, 0. So we have x and clearly y is 0, clearly y is 0. So to find, they say the point where the graph cuts the x-axis. So where the graph cuts the x-axis means, right, that y is equal to 0, all right? And this is basically what we did in part C. In part C, remember, this is the same thing as if you have f of x equal to x squared plus 12x plus 32 is the same thing as saying y is equal to x squared plus 12x plus 32. All right, y and f of x is the same thing. So if y is 0, f of x is 0. So instead of f of x, we have 0 instead, which is basically what we have here. Instead of f of x, or instead of y, we had 0. And this is what we worked out. All right, and we worked it out to be, where is that? That's here, minus 4 minus 8. So all the way back, let me just get some space. Let me just erase some things there. What was it? Minus 4 minus 8. So where it cuts the x-axis, it cuts at minus 4 minus 8. All right, so since we have everything there, I'm going to just draw the sketch right here and done. So we don't have to move through all those slides. And this will be the end of this video because this video ended up being very long. I have another question to do for you in the next tutorial. All right, so what we know, we have our x and y axis, right? We know this is our x-axis and we know that this is our y-axis. We know the minimum point is minus 6 minus 4. So minus 6 on the x and minus 4 on the y. All right, so let's just say there's minus 6 minus 4. What else we know? We know the value of the y-intercept is 32. So the graph is cutting the y in the y-axis, sorry. The graph is cutting the y-axis at 32, right? The y-intercept means where the graph cuts the y-axis. So the value of the y-intercept is 32 because C is 32. C is the y-intercept. All right, and they want us to also show where the graph cuts the x-axis, which is minus 4 minus 8. So that means we have a minus 8 here, the graph cuts here, and it also cuts here at minus 4. So I remember it's a minimum. We worked it out to be a minimum because A is greater than 0. A is 1, which is greater than 0. So it's a minimum, right? Minimum means it shapes like this, right? It cuts the x-axis at these 2 points. And it cuts the y-axis at 32. All right, and you just complete your curve. Of course, when you do it on your graph paper or the sketch in your book, it will look a little better than what I have on the screen. All right, so basically that is our sketch. And for the last one, to calculate the axis of symmetry, remember the axis of symmetry, our formula is, did I give it to you? Minus b on 2a, nope, it didn't give it to you. All right, so to calculate the axis of symmetry, it's basically minus b on 2a. We know how to get b and we know how to get a, but let's go through it again. All right, so the question told us we have x squared plus 12x plus 32. So this is in the form of ax squared plus bx plus c. So a is whatever in front there, which is 1. B is in front of there, which is 12. And c is on top there, which is 32. So we have A is 1, we have B is 12, and we have C is 32. All right, so the axis of symmetry, X is really X. X is equal to minus B on 2A. So X is equal to minus B over 2A, which is minus 12 over 2, which is minus 6. So our axis of symmetry is X is equal to minus 6. We're finished. So thank you so much for tuning into this tutorial. If you reached to the end, I'm so happy. Remember, like, subscribe. For part 2, you will see somewhere on the screen. You can click it and you can go ahead now. Also, follow me on Facebook, follow me on Instagram. Toodles.